Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
Voyager 1's new data reveals a powerful magnetic force beyond the solar system, defying expectations. Scientists believed the sun's shield was impenetrable, but cosmic rays are now breaking through. Stay tuned as Voyager's discoveries challenge everything we know about space and our fragile place within it. Cosmic rays, fading shields, and the future of Earth. Picture Voyager cruising out at over 14 billion miles from Earth. That's not just far, it's practically unfathomable. Yet even at this distance, this aging probe is still managing to send back data that leaves scientists scratching their heads. The highlight? A whole new magnetic field. Something never anticipated. Not weak, not fading. This is a strong, intricate force that's got everyone rethinking what lies beyond the comforting boundaries of our solar system. It's as if space itself just decided to rewrite the rulebook. In the quiet of deep space, a discovery appears, hinting at ancient secrets waiting to be uncovered. For years, scientists thought the sun's magnetic influence fizzled out at the heliopause, the supposed border between our solar system and interstellar space. Voyager was expected to confirm this assumption, but instead, it's like it stumbled into an intergalactic twist ending. A magnetic force, complex and dynamic, pulses out there. This isn't just a quirk of physics, it's a game changer for everything from interstellar travel to understanding the universe's structure. Let's dig into the unsettling stuff. Alongside this bizarre magnetic field, Voyager picked up an increase in cosmic rays, high-energy particles that typically come from explosive cosmic events like supernovas. These rays were supposed to be held at bay by the sun's protective bubble. Surprise? They're not. The spike Voyager detected wasn't just noticeable, it was alarming. If the sun's defenses are weaker than we thought, what does that mean for Earth? For astronauts heading to Mars and beyond? For the satellites we depend on every day? None of it sounds good. Cosmic radiation is no small issue. It's the invisible menace of deep space, capable of frying electronics and wreaking havoc on human health. The fact that Voyager encountered such intense radiation raises urgent questions. Are humans anywhere near ready to step beyond the sun's protective embrace? If not, then space colonization, the dream of becoming a multi-planet species, could remain just that, a dream. And it doesn't stop there. Voyager's findings suggest there's more out there than just cosmic rays and magnetic surprises. The interstellar medium, the vast, mostly empty region between stars, turns out to be anything but simple. Scientists assumed it was a quiet, static place. Voyager found a dynamic, fluctuating environment that defies expectations. Plasma waves, unexpected density changes, and those weird magnetic fields all point to forces we barely understand. It's like unlocking a door to a room you thought you knew, only to find it's packed with things you can't even name. NASA, for all its brilliance, is now in a race against time. Voyager is old, running on its last bits of nuclear power. Every piece of data it sends back is precious because soon it'll fall silent for good. Yet the agency's response is as ambitious as the discoveries themselves. They're not just poring over Voyager's data, they're preparing new missions to delve even deeper into interstellar space. These aren't just science experiments, they're survival strategies, steps toward ensuring humanity can navigate and maybe even thrive in the harsh realities of the cosmos. Here's where it gets even wilder. These discoveries aren't just theoretical, they have real, immediate implications for Earth. If cosmic radiation can penetrate deeper into the solar system than we thought, our planet's satellites, those that power communications, GPS, and even weather forecasting, could be at risk. Imagine losing those conveniences, not to mention the catastrophic consequences for global security and infrastructure. This isn't sci-fi, it's a looming reality, and it all ties back to the sun's supposed protective shield being less effective than advertised. As Voyager's findings sink in, new questions emerge about humanity's place in space, the spacecraft that redefined our universe. Then there's the philosophical angle. If our heliosphere, the protective bubble created by the sun, is this vulnerable, what does that say about our place in the universe? Humanity has long viewed itself as perched in a relatively safe corner of the cosmos. The spacecraft's data suggests otherwise. The forces at play in interstellar space aren't just distant phenomena. They're a reminder of how fragile and interconnected our existence is with the greater universe. Meanwhile, the private space industry is charging ahead with plans for Mars missions, lunar bases, and beyond. SpaceX, Blue Origin, and other players are all betting big on humanity's future in space. But are they ready for what the probe is revealing? The answer right now seems to be no. Radiation shielding, propulsion systems, and life support technology will all need a significant upgrade to handle the challenges lurking beyond the heliopause. And then there's the tantalizing unknown. What if the craft's discoveries point to something even more extraordinary? A new type of matter or energy. An unknown cosmic structure shaping the interstellar medium. These aren't just idle questions. They're the kind of mysteries that could redefine not only space exploration, but science itself. For all we know, the mission has stumbled onto clues about the very nature of the universe. Clues we're just beginning to decode, but it's not all doom and gloom. These challenges are also opportunities. Understanding the interstellar medium and its quirks could lead to breakthroughs in propulsion technology, radiation protection, and even new ways of harnessing energy. The same forces that threaten our satellites and astronauts could, with the right knowledge, become tools for advancing humanity's reach into the cosmos. The journey against all odds continues to be a beacon of discovery. It's not just a relic of the past, it's a messenger from the unknown, challenging us to confront the universe as it is, not as we wish it to be. And while its mission will eventually end, the questions it's raised will fuel exploration for generations to come. Because if there's one thing the spacecraft has taught us, it's that the universe is far stranger and more exciting than we ever imagined. To truly appreciate the magnitude of its impact, consider this. The heliosphere's behavior affects not just the edge of the solar system, but Earth itself. The unexpected cosmic rays breaching what was once considered a robust shield can disrupt everything from electrical grids to global communications. Imagine airplanes losing GPS signals mid-flight or weather models failing due to satellite malfunctions. These scenarios are not mere speculation. They are real risks tied directly to the vulnerabilities exposed by its findings. Scientists are now racing to model and predict these changes, but they're working with incomplete data. The instruments, though groundbreaking for their time, were never designed to measure the phenomenon now being encountered. Yet even limited, the data paints a startling picture. Magnetic fields twisting unpredictably, bursts of radiation, and waves of plasma are creating a chaotic interstellar environment. The question isn't just what's causing this chaos, but how humanity can adapt to it. The adaptation might require a complete overhaul of current spacecraft technology, new shielding methods to block cosmic rays, advanced navigation systems to account for shifting magnetic fields, and propulsion systems capable of withstanding unknown plasma environments are just the beginning. Private space enterprises may need to collaborate more closely with NASA and other government agencies, pooling resources and expertise to tackle these challenges head-on. And while the focus is often on astronauts and satellites, the implications for everyday life are just as significant. On Earth, we rely on a delicate balance of technological systems, many of which extend into space. The internet, banking systems, and even emergency services could face disruptions if interstellar phenomena grow more pronounced. The revelations are not just academic. They demand practical responses to ensure global stability. The broader scientific community is grappling with questions that extend beyond immediate concerns. What do these findings say about the nature of space-time itself? Could the anomalies uncovered point to new dimensions or undiscovered particles? Physicists, astronomers, and engineers alike are diving into these possibilities, knowing that the answers could revolutionize multiple fields of science. Consider, too, the long-term implications for human exploration. If interstellar space is this unpredictable, how should humanity prepare for missions to distant stars? The dream of reaching exoplanets, worlds orbiting other suns, now seems even more daunting. But daunting does not mean impossible. It means rethinking strategies, investing in research, and embracing the unknown with the same spirit that launched the probe decades ago. In October 2024, the spacecraft encountered a major problem. Its fault protection system unexpectedly shut down the primary X-band radio transmitter. That transmitter is the spacecraft's lifeline, responsible for sending vital scientific data and updates back to Earth. This left NASA engineers no choice but to revert to the old S-band transmitter, a device last used in the early 1980s. The S-band wasn't built for modern communication needs, and the signal quality was far weaker than desired. The team at NASA's Jet Propulsion Laboratory in California acted swiftly. By early November, they managed to revive the X-band transmitter, restoring full communication and ensuring the steady stream of data could continue. This quick fix showcased the ingenuity and determination of a team managing a spacecraft that's outlived every expectation. Its ability to function relies on radioisotope thermoelectric generators. These power sources convert heat from decaying plutonium into electricity. However, they lose roughly 4 watts of power every year, forcing NASA to carefully shut down non-essential systems to conserve energy for critical instruments. Remarkably, even in temperatures far below anything the spacecraft was originally designed to handle, its instruments keep working, offering a window into the mysteries of interstellar space. This mission's success owes much to Ed Stone, the visionary scientist who guided the program for decades. Until his passing in June 2024, Stone's leadership drove the spacecraft through groundbreaking achievements, including its historic entry into interstellar space, a boundary few thought possible to cross. Looking ahead, NASA estimates the spacecraft will continue to send data until at least 2025. With a bit of luck, it might even keep transmitting into the early 2030s. For a spacecraft launched in 1977, still operating and contributing to science, this is nothing short of extraordinary. Its story is a testament to human ingenuity, resilience, and the enduring curiosity that drives space exploration. With Voyager paving the way, let's see how other missions changed our view of the universe. A tour of the cosmos. Let's not forget, Voyager 1 isn't the only star player in the deep space exploration game. It's got some serious company. Let's dive into the stories of these probes, their groundbreaking missions, and how they've changed the way we see our universe. Picture this. It is the early 1970s, and NASA decides to send a couple of spacecraft beyond the safety of Earth to explore the unknown. Enter Pioneer 10 and Pioneer 11. These two were the first to boldly navigate the asteroid belt, a chaotic highway of rock and debris. Pioneer 10, launched on March 2, 1972, was the first to make a close flyby of Jupiter. It sent back mind-blowing images of the gas giant, capturing its swirling clouds and monstrous storms. Beyond pictures, Pioneer 10 also gave us data on Jupiter's magnetosphere and radiation belts, information that laid the groundwork for every mission that followed. Hot on its heels came Pioneer 11, launched on April 5, 1973. After a successful stint with Jupiter, it headed straight for Saturn. It was the first spacecraft to give us a close look at Saturn's rings, those delicate bands of ice and rock that still mesmerize astronomers. These pioneers didn't just collect data. They carried golden plaques inscribed with information about Earth and humanity, a cosmic message in a bottle for anyone out there. While Voyager 1 gets a lot of the spotlight, its sibling, Voyager 2, is the real champion. Launched on August 20, 1977, it is the only spacecraft to have visited all 4 gas giants: Jupiter, Saturn, Uranus, and Neptune. Voyager 2's journey was like a greatest hits tour of the outer planets. It uncovered active volcanoes on Jupiter's moon Io, discovered Uranus's faint rings, and captured stunning close-ups of Neptune's moon Triton, complete with icy geysers. The data from Voyager 2 did not just expand our knowledge, it rewrote textbooks. This probe proved that the outer planets and their moons are dynamic and fascinating, not just cold, dead rocks. And like its sibling, Voyager 2 eventually crossed into interstellar space, giving us a second set of eyes on the cosmos beyond our solar system. Pluto, once a full-fledged planet and later downgraded to a dwarf, finally got its moment of glory thanks to New Horizons. Launched on January 19, 2006, this spacecraft was designed to give Pluto the recognition it deserved. When it flew past in 2015, the images and data it sent back were jaw-dropping. Who knew Pluto had mountains of solid ice, vast plains, and even a thin atmosphere? But New Horizons didn't stop there. It pushed further into the Kuiper Belt, a region full of ancient, icy objects. In 2019, it flew by a strange, snowman-shaped object called Aerokoth, offering a glimpse into how the building blocks of planets formed billions of years ago. New Horizons has been like the friend who doesn't know when to quit, and we're all better for it. Launched in 1989, Galileo was all about Jupiter. It wasn't just content with a quick flyby. It went into orbit around the gas giant in 1995 and stuck around for years. This mission was a deep dive into Jupiter's atmosphere, magnetic field, and its entourage of moons. The big finds included oceans of liquid water beneath the icy crusts of Europa, Ganymede, and Callisto. These discoveries fired up imaginations and questions about the possibility of life in these hidden seas. Galileo also captured incredible images of Io, the most volcanically active body in our solar system, where lava flows and volcanic plumes are part of everyday life. Galileo was a game-changer, proving that moons could be just as interesting as planets. Cassini-Huygens was a collaboration between NASA, the European Space Agency, and the Italian Space Agency, launched on October 15, 1997. Cassini spent 13 years exploring Saturn and its moons, while the Huygens lander made a historic touchdown on Titan, Saturn's largest moon, in 2005. The findings were nothing short of revolutionary. Titan turned out to have lakes and rivers, not of water but liquid methane. Meanwhile, Cassini discovered geysers shooting water vapor and organic materials from Enceladus, another of Saturn's moons. These discoveries hinted at the possibility of life in the most unexpected places. Cassini also gave us the clearest views of Saturn's rings and revealed the intricate dynamics of how they're shaped by the planet's moons. Launched in 2011, Juno has been orbiting Jupiter since 2016, peeling back layers of the planet's mysteries. Unlike Galileo, which focused on the moons, Juno's mission is all about the planet itself. It has been studying Jupiter's gravity, magnetic field, and deep atmospheric dynamics. Thanks to Juno, scientists now have a clearer picture of Jupiter's chaotic weather systems, including its iconic Great Red Spot, a storm so massive it could swallow Earth. Juno's close passes have also provided stunning images of Jupiter's poles, revealing swirling, hurricane-like storms that look like works of art. The Parker Solar Probe, launched on August 12, 2018, is a daredevil. It is traveling closer to the Sun than any spacecraft before it, enduring temperatures of over 2,000 degrees Fahrenheit to study the Sun's corona, its outer atmosphere. The goal is to understand solar wind and magnetic fields, phenomena that directly impact Earth by disrupting satellites and power grids. As Rosetta unlocks secrets of the cosmos, one question lingers. Could the life we cherish on Earth owe its origins to ancient cosmic travelers? Like, comment, and subscribe to join the discussion.